All right, here we are. We are working on problem number 26 out of the review. And I've got it sketched out on the paper, and what I want to do is walk through how we label everything to help you understand how everything is related to one another. So let's see over here, let's call this resistor A. It is 3 ohms. Then as you travel from the battery from resistor A, you hit a junction point in the circuit. So from that junction point, you're going to come up. Along the upper path, let's call this resistor B. It is 3 ohms also. And then along that same path, you hit another junction point. Going on the top, let's call this C. It is 6 ohms. And going below it, let's call that D. It is also 6 ohms. Now, a junction comes together, a junction comes together. So what that means is, after A, there's a parallel. Starting right there. And that parallel ends right here. Then you come up, you go through B, another parallel begins, another parallel ends. Therefore, C is parallel to D. C and D are in a series with B. B, C, and D is parallel to this stuff we have yet to talk about. Let's talk about that now. Now we need to know, let's see, A, B, C, D. E is 4 ohms, F is 12 ohms, and over here G is 2 ohms. Our destinations in the problem are F and G. So that's our goal. So what we want to do is start figuring out resistance, and that's what our tables is kind of the big deal. Now, I'm not going to have room for the whole table on the page. I'm not going to solve everything, as a matter of fact. I'm going to let you solve, but I'll kind of show you what's related to what. So starting here, we have equivalent resistance. That's our total level resistance. Then, let's see, our goal is F and G. So let's say, big picture first here. We have A, resistance A, and resistance B through G. So that's all of this. Okay, that's that whole big thing. Break B through G down into resistor B, C, D, and resistor E, F, G. Now, let's basically ignore B, C, and D for this problem because we really care about F and G. So we have, inside that, we have resistors E and F and resistor G. So that's in a series with each other, and then we have resistors E and resistor F. And I'm going to start trailing off the page if I go any farther. Truth be told, we would have, let me adjust my view here, we have BCD up here. We would also have, in the unimportant section of the problem, resistor C and D, resistor C, resistor D, and resistor B to deal with. But those don't matter. We are not going to address those, so let me readjust my view. So, to do the problem, we have to work these guys out. So we got to work out our parallels, and then we have to work out the series, and then the big parallel, and then the big series. So let's see. If we have a C and a D here that are both 6 ohms, and you do 1 over 6 and 1 over 6 deal with those, with C and D, that's going to be 2 over 6, which is equal to 1 over 3, and when you take the reciprocal, C and D is going to give you 3 ohms. Down here, you're going to have 1 over 4 and 1 over 12. And then if you put that in twelfths, this one here would be 3/12. And if you do 3/12 and 1/12, you get 4/12. 4/12, take the reciprocal, you get 12/4, which that would mean that E and F is 3. So E and F is 3 ohms, C and D is 3 ohms. So then up here again, this right here we just solved to be 3 ohms. Sorry, it's not an M, it's a circled 3 that's sideways. So 3 ohms is in a series with 3 ohms. B is 3, CD together is 3, therefore it's a series. BCD is 6 ohms. Down the lower branch, we solve this to be 3, therefore we have a 3 and a 2 in a series. And in a series, we add those up, so 3 and 2 is 5 ohms. We fill this in, 2 ohms, 4 ohms, 12 ohms. We don't care. A is 3 ohms. Okay, now we gotta do B through G. So B through G is having a 6 ohm top branch and a 5 ohm bottom branch. So now we gotta do a little fraction deal again. 1 over 5 plus 1 over 6. Best common denominator would be 30s. So that'd be 6 thirtieths and 5 thirtieths. So that equals 11 thirtieths, which when you take the reciprocal is 30 elevenths. And don't quote me on this in a quarter law, but I'm fairly certain that comes out to 2.7 ohms. So now what we have, and let's come down here, is what we have a circuit where it has A in a series with B, C, D, E, F, G. This is 3, and that's 2.7. That's everything but A. So that's a series, therefore, readjust. Therefore, the equivalent resistance is 3 plus 2.7, 5.7 ohms. Now, we have to start doing current and voltage. I'm not going to solve those out for you. I will point to where they are the same. I'll draw arrows, but I'm not going to solve them out for you. So we would have, let me adjust over here, current total, voltage total, current A, voltage A, resistance BG, I'm sorry, current BG, voltage BG, current BCD, voltage BCD, current EFG, voltage EFG, current EF, voltage EF, current G, voltage G, current E, voltage E, current F, voltage F, and we don't care beneath that. Now, total voltage is 18, I think, from the problem. Now, what you're going to do is you're going to use Ohm's law. You are going to solve for the total current. Then you're going to say, what we did down here, A and B through G was a series. I know it's off the page, but you humor me. That was a series. Therefore, in the series, the current is the same. Current is the same. Okay? We used a rule for that. Current was the same. Now, we don't care about A. We care about voltage B through G. And so we're going to solve for voltage B through G. That's our square. Now, once we have voltage B through G, what that means is voltage B through G is the voltage along the top branch, and it's the voltage along the bottom branch. Those are going to be the same by rule in a parallel. Those will be the same. Therefore, whatever you get here will be the we don't care and we do care. Off the screen, sorry. Voltage B through G is the same as voltage BCD and voltage EFG. Now, we have two things. We must solve for a new one. So we used a rule to get that. So now we're going to solve. And here we are. We're going to solve for the current there. Now, EFG is one series. Therefore, in both parts of this series, part EF and part G, it will have the same current. EF will have a current of a star. G will have the current of a star. Because of the rules. Now, we care about this stuff. So you're going to solve. You're going to solve for this one. Okay? And then you're going to solve for that one. Because you need to. So those are two things you have to solve for. Now, we don't care about E, but we do care about F. So we have voltage EF, and as you can see, EF is a parallel. Therefore, you will take your voltage for EF and put it there, and you will also take your voltage for F. Okay? So let me kind of like that. Okay? Now, let's see. The problem asks us the current in the 2, the voltage in the 2, the current in the 12, the voltage in the 12. So, answer, 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 answer. So now we use Ohm's law and solve for that using those. So I know that was a lot of steps right there. Okay? So working through it with resistance, we solved for resistance CD. We combined CD with B to get BCD. We solved for resistance EF, combined it with G to get EFG. Then we combined BCD and EFG to get B through G. Then we combined it with A to get the total. Then we used total voltage from the circuit to get the total current. We said that A and BCD, B through G, was a series. So we used our rule to distribute that current. We used Ohm's law with B through G to get the voltage, B through G. Then we said BCD and EFG are the two branches in that parallel, therefore they have the same voltage. Then we calculate our current through EFG. EF and G are in a series, therefore they got the same current. We calculated voltage EF. We distributed that because E and F is a parallel, so we distributed that voltage. We calculated the current F. We also were able to take the current from G here and go this way and get the voltage. That's that problem right there. A lot of stuff, but you can do it.